Hello all. Today we will be looking at the solutions for assignment 8. So question number 1, consider the Boolean expression f of abcd equal to so on. Right? For this expression, it's asking whether it follows the mirroring property. So the mirroring property in essence is basically f of a bar, b bar, c bar uh, is equal to f bar of abc. If this holds, right, that means the mirroring property holds. So let's look at it. The expression can be reduced as shown here to AB plus BC plus CA the whole bar. Now, when you go back and write down the truth table for ABC and F, right, you will obtain this table, and you can see from the colors here, which is yellow, red, blue, and orange, that F of, for example, A bar, B bar, C bar, in this case, A bar, B bar, C bar would be 1, 1, 1, and the expression for that, the value for that will be 0. Right? So you can see that it turns out to be 0. Similarly, you can verify for all of the other colors, which is red, blue, and brown, that it follows the mirroring property. Similarly, question number 2 asks for if this expression, right, obeys the mirroring property. So we already know that A XOR B XOR C obeys the mirroring property, which is basically the sum expression. However, from which you can directly write down this statement and realize directly that it does follow the mirroring property. Or you could go back and write the truth table like this and verify that all of this, right? So when you say a bar, b bar, c bar, which is 1, 1, 1, and 1, so you will get this expression. So you will, if you trace back to the colors yellow, red, blue, and brown, like you will see that the mirroring property holds. That's question number 2. Question 3. For a pseudo NMOS inverter, if the VOL is 0.05, what is the ratio of WN by WP? Yeah, so when you go back and write down the regions for these transistors, which is the PMOS and the NMOS, you will obtain that the PMOS is in velocity side and the NMOS is in linear. So here are the expressions for the NMOS and the PMOS, right? So once you write down the expression, it is a matter of plugging the values in and obtaining the result, right? So you plug the values here as shown in this calculation and finally obtain Wn by Wp as so much. I'll just give it a minute so that you can look into the calculation and the work. Yeah, so we can proceed now. Let's proceed to question number 8. What is the fall logical effort for any input in a dynamic footed four input NOR gate, right? So question number 8 is dealing with a dynamic footed four input NOR gate, which is as shown here, and the reference inverter for the fall is as shown over here. Um, Now, when you go back and write GA, it would be just 2, which is this, and divided by 2 plus 1 from here, and then you get 2 by 3, right? That's how you obtain the answer to question 8. And question 9, what is the Rice logical effort for any input in a pseudo and MOS 4 input NOR gate? Again, let's look at the circuit. So here's the circuit for it. Pseudo NMOS 4 input NOR gate, and the reference for rice is as shown here, which is 2 by 3 and 1 by 3 for the PMOS and the NMOS respectively. And the GU is calculated as 4 by 3 from here and divided by 2 by 3 plus 1 by 3, which is 4 by 3. Right? That is the rice. And accordingly, the fall is also given here. But however, we are concerned with the rice logical effort, which is 4 by 3. Right? That's question number 9. Going to question number 10. Determine the VIL of the inverter INV. Assume the noise margin approximate value for the calculation. Right? So from uh, what was discussed in class, the noise margin approximate calculation for VIL, right, is as shown here. And again for question number 11, VIH is as shown here, right? So when you look at these expressions and calculate the value for VIL and VIH, you will obtain 0.95 and 1.05 respectively for question number 10 and 11. So here is your answer in this one, right? Finally, question number 12. Uh, if there will be a static so if in case the input in rises to VD during the precharge phase itself and remains at VD through the valve phase, then which of the following statements are not true? Right? So what it's saying is the input was zero during the previous eval phase and it rose to one in the precharge phase itself. Now it remains constant all throughout the precharge as well as the eval phase. Now it's asking if the first option is there will be a static current discharge from VDD to ground from the PMOS transistor to the NMOS stack during the precharge phase. So when we look at what happens during the precharge phase, uh, the transistor has so during the precharge phase the clock is zero here, and again this is zero. Since the NMOS is now cut off, right? So you do not have any current path this way. Hence, there will not be any static leakage path during the precharge phase. Now, if the previous state of out was 0 volt, then out will continue to float at 0 volt in the precharge phase. Yes, that's true. Let's say this was at 0 volt. In the precharge phase, even let's say the in, even if in was 1, in our case it is 1, even if it was 1, it cannot discharge it down to discharge this. I mean, in the case of 0 volt, it will remain at 0 volt. But let's say if there was a different voltage over here, right? Let's say the next option asks for um, if the previous state of out was 2 volt, out will be held at 2 volt in the pre-charge phase. So let's say there was 2 volts over here, right? So even though in is at 2 volt, let's say, it doesn't have a path to discharge anywhere, and hence this 2 volt will be floating at 2 volt. There will still be some amount of leakage if leakages are counted, but however, that's why it would float at 2 volt. Last option, there will be a static current path from VDD to ground from the PMOS transistor to the NMOS during the evaluation phase, right? Yeah. So during the eval phase, what happens is, let's say that, okay, here 0 and 1 means 0 and VDD. So here, during the eval phase, the previous state would have been 1 and the 1 would translate to the inverter's output being 0, which would translate to this PMOS being on. And since it's sufficiently sized as size 8, there will be a fight or contention between the PMOS stack and the PMOS and the NMOS stack. Right, so there will be a static discharge path from VDD to ground. Yeah. Thank you. You could ask any of your questions regarding the solution on the board. Thank you very much.